Here we go. We're going to go ahead and take notes in our notebook. So get your graphing composition notebook, open it to the next clean page. We're going to start on the left-hand side and let's title it 3.3.1 Division with Rational Numbers. Okay, we're going to start with 3-87 and pause this video at any time if you need me to slow down or if you need to write anything down for yourself. Okay. So a fraction is just really a symbolic representation of the quotient of two quantities, and this is an answer to a division problem. So when we think quotient, we're thinking the answer to a division problem. The fraction 3/4 really means 3 divided by 4, and that equals 75/100. Remember, we can rewrite our fractions as decimals and percents and words. In this lesson, you will work with dividing fractions, positive and negative mixed numbers, and decimals, okay? So let's look at this one right here. The first thing I want to note is that a rational number is any number that can be written as a quotient or fraction of integers that is in the form a over b, okay? So we're going to rewrite this. A rational number, rational for math, and I'm going to put 3 lines for definition, right? And this means you can rewrite as a fraction. Okay. And then it says in that form a over b with the denominator not equal to 0, right? So a and b can be any numbers, but we have to make sure the denominator, the bottom number, is not 0. Okay, so the first question says, and we're going to put a here, it says, what mathematical operation does a fraction represent, right? And a fraction is just a division problem. Right? So don't tell me that I never taught you this, okay? Right? And if we use an example, so just like the example in the introduction, if I have 3/4, this is the same thing as 3 divided by 4, right? This is the same thing as 75/100, right? And I want you to look, if you think of the division sign, right? A fraction is just a division problem, but instead of numbers, there's dots, right? So when you see that fraction, I want you to think it looks like a division sign, but instead of these numbers, you just put dots there, right? So the dots represent those numbers. Okay, let's go ahead and rewrite this. I also want you to know one other thing, that this is 3 divided by 4. So a lot of my students are always putting like the bigger number underneath, but it's 3 divided by 4. And I know we're going to be working with decimals and you just have to be comfortable with that. Get used to being uncomfortable with it. Okay, so B, right? We're going to go ahead and rewrite this. So it says represent each division problem below as a fraction. So if I take the first one, this is 2 divided by 8. Right? I'm going to rewrite this as 2/8. Okay. For the second one, I'm going to rewrite this one. This is 72 divided by 5. And I'm going to rewrite it as 72/5. Notice that no matter what, the first number right here is going into the numerator on top. The second number right here is going into the denominator on the bottom. Okay, and then part 3, let's try this one on our own. So we have 51 divided by 94. So go ahead and write what you think the fraction would be. And here it is. So same thing. The first number is going to be our numerator, so 51 over 94 in our denominator, right? The bottom number. Okay. For C and D, I want you to actually give me your opinion on this, right? So either write it down in your notebook, or if you are on Edpuzzle right now, I want you to actually type that into Edpuzzle. So we're going to put Edpuzzle, right? And I just want to know your opinion on this, right? So it says, why do you think that the denominator of a fraction cannot equal 0? And if you want, test it out with your calculator, see what happens, or ask Siri what happens, right? For D, it says, when would it be most useful to use a fraction to find the answer to a division problem instead of using long division, right? So when is it more useful to use a fraction instead of using long division? Okay. We're going to go ahead and skip 388. And then 389, it says, Hui Madison and Ramona were working on the following problem and each began her work differently. So the problem is 1 3/8 divided by 3/4. I want you to focus on Madison and Huey, right? So look at their work. And we might touch on Ramona's later, but I really want you guys to focus and be able to master these two concepts. Okay, so if you cannot see it on this video, please go to this section, this 3.3.1, either in your ebook or on your textbook. And I want you to look at it and I just want you to tell me, what do you notice, right? Okay, so looking at this one, 1 3/8, what she did was she turned it into an improper fraction, right? So what she did was the 1/8, 1 whole would be 8/8, and that, so 8 plus 3 would be 11. And then the 3/4, what she did was she turned it into 6/8, so unsimplifying, right? We can actually write this down. So 3 dash, this is 89. Right? And we're going to go ahead and write Madison for the first one. Okay. So this is 1 3/8, and this one whole would be 8/8, right? Just using that same denominator. So if I have 1/8, 8/8 and 3/8, this will give me 11/8. That's how she got that. Okay. The second part, if I have 3/4, right? If I use my giant 1 and I just multiply by 2/2, there's my giant 1. Right? This will give me 6/8. Okay? And then what she did was, if I look at this, if I did 11/8 divided by 6/8, right? What we're looking at is 11 divided by 6 in my numerator, 8 divided by 8 in my denominator, and this gives me 1, right? In my numerator, it's 11/6, right? So if I have 1 in my denominator, then this is just 11/6, and I can just focus on this, okay? In your answers, for me, depending on who your teacher is, but for me, if it's an improper fraction, I'm okay with that, right? Which means improper meaning the number on top is bigger. Okay, they simplified it to 1 5/6, and that's okay too. But I think that from there to there, there's room for mistake. Okay, and I just wanted to note one more time, this denominator, this over 1, right? It's still there. You just don't need to be able to write it. So 3/1 is the same thing as 3, right? So this is like this side note that we're looking at. Okay. For Huey, I need to go to another space. So let's go ahead and go and move more space for myself. All right, and I'm going to write Huey right here. Okay, so what Huey did was he had 1 3/8, and this is divided by 3/4. Okay, what he did, looking right here, is he made it into a complex fraction. A complex fraction is actually a fraction within a fraction, right? So I have 1 3/8 in my numerator, just like how we had it earlier, right? So that first number goes on top, that second number goes on the bottom, right? And when you look at this, you can see the order of what you need to do things, okay? Same thing, this one is turned into an improper fraction, right? So we did that already. I'm just going to rewrite it over 3/4. Right? Here's where Huey does his part in dividing the fraction. So I'm going to rewrite it again. 11/8, right, is my numerator. 3/4 is my denominator. Notice that I made that fraction bar in the middle a little bit bigger. And what he did was he multiplied by a giant 1. Right? If I multiply by 4/3 over 4/3, right, this, right, anything over itself is going to give you 1. Okay, so looking at this, why do you think that Huey chose 4/3? Right? This is the reciprocal of my denominator. So if I multiply straight across, right, going straight across right here, 3 times 4, this gives you 12. 4 times 3, this gives you 12. Boom, I have 1 in my denominator. Again, I don't have to write anything with that anymore. Okay. In my numerator, so that's where his 1 comes in right here. In my numerator, multiplying straight across, 11 times 4 is 44. 8 times 3 is 24, right? And then what he did from there is you can drop that 1 in the denominator because 3 over 1 is 3. So 44 24ths over 1 is just 44 24ths. Okay. What he did from there was he turned it into a mixed number. What I need from you, the bare minimum, is to simplify, right? So when I look at this, I know they're both even, so I can divide by 2 over 2. That works. Right? If I do that, dividing straight across, because I can see 44 divided by 2 is 22. 24 divided by 2 is 12. And oh, look, I can simplify one more time, right? So still going again, I'm going to move down to the bottom. If I have 22 over 12, I can divide by 2 again and use my giant 1 and just simplify. This is how we simplify. Right? 22 divided by 2 is 11. 12 divided by 2 is 6. And that gives me the same answer that I had before with Madison, right? 11 over 6. Or if I turn it into a mixed number, it'll be 1 and 5, 6. But again, I am okay with this one. I do want you to simplify, but I'm okay with this one. Okay? So your task is, and go ahead and write underneath, is to use one of these methods, right? And it's okay whichever method you use to do these two problems, right? So I'm going to find some more room. And this is going to write, so for A, it's going to be 4/5 divided by 1/2. And B, I'm going to write 2 1/2 divided by 3/4. Take a second, work on these problems on your own, tell me what you get, and then we'll move on. Okay, so for this one, for the first one, what I'm actually going to do is I'm going to do Madison's method. Okay, so what she did was she found the same denominator, right? So what we need to do is to find the least common denominator. And I know already that my LCD is 10. If you don't know how to find the LCD, find the other video that's the least common denominator, and then you'll be able to find it. Okay, so converting these fractions, I have 4/5. I need to have 10 in my denominator. So I'm going to use my giant 1. I'm going to multiply by 2 over 2 for this one because I know that 5 times 2 equals 10. So I'm going to go ahead and multiply straight across. This gives me 8/10. For 1/2, I need 10 in my denominator. So how do I go from 2 to 10? What do? I multiply by 5 over 5. Here is my giant 1. 2 times 5 is 10. 1 times 5 is 5 in my numerator. And now I can divide straight across, right? So this is the whole point. I needed to work a little bit backwards in order to move forwards. So instead of 4/5, I now have 8/10. Instead of 1/2, I have 5/10. And now I can divide straight across, right? So 10 divided by 10 gives me 1. 8 divided by 5, right, gives me 8/5. And I know that if my denominator is 1, I can drop that as a number and it just like simplifying it even more. And this gives me 8/5, right? And I am okay with this answer because it's simplified and it's improper, and that's okay. Okay. For the second one, if you turn this into a mixed number, it should be 1 3/5. Okay. Either one works. So for the second one, I'm going to use my giant 1 method. So I'm going to use Huey's method, right? And I'm going to change this one into an improper fraction first, right? So 2, meaning I have 2 over 2, that's 1. 2 over 2, that's 2, right? So 1 and 2. And then I have my 1/2. This gives me 5/2 divided by 3/4. What Huey did was he made into a complex fractions, meaning I have 5/2 over 3/4, right? Again, I need to multiply by a giant 1, so I need to multiply by the reciprocal 4/3. And if I do that into my denominator, I do it to my numerator too. Here is my giant 1. and I can just multiply straight across, right? 3 times 4 is 12. 4 times 3 is 12, and this gives me 1 in my denominator, so I don't need that anymore. Multiplying straight across, 5 times 4 is 20 over 2 times 3, which is 6, and now I can use this as my fraction. Okay, so 20 over 6, almost done. And again, if you're like, oh, where is this going? Just pause and rewind, right? That's the beauty of these videos. 20 over 6, I can simplify this, right? So if you give me this answer, I will give you a majority of the points. But to go further, I need to divide. Let's do by 2. There's my giant 1. If I see an even number, most of the time I just go for 2. 20 divided by 2 equals 10. 6 divided by 2 equals 3. And that is a simplified improper fraction. Okay, if not, 3 and 1/3 also works. That is the mixed number for that. Okay, 390. So, last part. I want to set this problem up for you, and then I want you guys to try it on your own. So it says using two methods, which is finding a common denominator, right? And then using a supergiant one, right? So here what we did, finding the common denominator. You guys have learned how to do this. When you're adding and subtracting fractions, you have to find the common denominator. Then you can just divide straight across, right? For this one, a little bit more complex. I actually really like complex fraction because it makes me feel like I'm doing a lot, even though it's simple as soon as you know how to do it, right? So this one, we make a complex fraction, multiply by the reciprocal of the denominator, right, to get that giant 1, and then you multiply straight across. So it depends on which you prefer, right? If you need to review these methods, look at the math notes. There's actually a toolkit video on this one. Decide which method you will use for A and B, and then write the problem as a fraction division problem, solve it, and then explain which division part. Okay, so here what we're going to do is I'm going to break it down for you guys, right? Word problems are hard. This is 3-90. Okay, what I'm going to do is I'm going to break down this word problem for you, and then what I want you guys to do is solve it whichever method you choose, right? So Gerard loves to cook. His aunt visited Switzerland and brought him back 4 pounds of Swiss chocolate. Gerard's favorite cookie recipe takes 3/4 pound of chocolate. How many batches of the chocolate cookie recipe can Gerard make using all the chocolate that he has? Right? Word problems are hard. Most of the time, at least in middle school math, right? What you can do is you can take the numbers and find out what's important, right? So from this problem, we have that's important. We have 4 pounds of chocolate. The other piece that we need is it takes 3/4 pound for each batch of cookies, right? So the recipe is 3/4 pounds, right? And he wants to know how many batches, right? So how many times can he make that recipe before he runs out, right? What we're looking at, the question is asking how many batches. Okay. So when you write down the question, it's really good because when you give me an answer, I want you to answer that question, right? So your label should be something batches. Gerard can make this many batches, all right? Okay, B. Lauren was bringing food to a party. She bought a 4-foot sub sandwich and cut it into servings that were 3/5 of a foot long. How many servings did she get if she used the whole 4-foot sandwich? Right, so most important things right here that we're looking at is a 4-foot sub sandwich, right? And then it was cut into 3/5 foot pieces. All right, so the question is here, right? And then when you think of you're cutting it into pieces, that means you're dividing it into parts, right? When you're making recipes, you're like, okay, 3/4 pound here, 3/4 pound here, 3/4 pound here. We're dividing that 4 pounds into the 3/4 pounds, right? It says, how many servings did she get? So the question is, how many servings, right? And I like these short bullet points because I'm like, okay, this is what I need to know. And if you take that out and you kind of have a sense of like which operation you're using, like multiplication, division, addition, subtraction, you can it's a lot easier to find the answers for this. Okay, so try these problems. Make sure you guys get to the end of the video. And then I don't know if we'll check in class or I'll just post the answers. I haven't decided yet. But anyways, do your best. Just try it and we'll do a lot of practice. And that's it. Thank you.